In the last video, I told you I would show you a faster way to graph linear functions, especially those in the non-standard form, those not in the form y equals mx plus b. And to prove that that is true, I'm going to actually do the exact same problems I did in the last video, but faster. So we did this one, y minus 2x equals 3, and we changed it into y equals mx plus b form, which for this one would only take one step, but there's still a faster way to do it. First we're going to set x equal to 0. So if we set x equal to 0, then negative 2x becomes 0, and we'll be left with y equals 3. Now since we put x to 0, the point is x is 0 and y is 3. If we do the same thing for the other variable, we set y equal to 0, then the y will disappear and we'll be left with negative 2x equals 3. X will be negative 3 over 2. And since we set y equal to 0, we have x is negative 3 over 2 and y is 0. Now look what happens here. This is where you really save time. If we just plot these 2 points, we have a y-intercept 0, 3 right there, and we have an x-intercept negative 3 over 2 right there. Now let's just draw a line through them. We can kind of get an idea of what the slope's going to look like. And we're done. Now the thing is, it's not perfectly accurate because you only plotted 2 points, and especially with this one, they're very close together. Now you could try to figure out the slope from these 2 points and then try to follow that accurately, but if you really want an accurate graph, it's probably best to just convert to y equals mx plus b form first and figure out what the slope is from the equation. But for a quick sketch, this is definitely faster, especially when you have, here's the other problem we did, negative 2y plus 3x equals 4. Instead of having to convert this into y equals mx plus b, set x equal to 0. So the 3x disappears, and you get negative 2y equals 4. Y is negative 2, so this is 0, negative 2. If we set y equal to 0, negative 2y disappears, 3x equals 4, x is 4 over 3, and so you're left with the point 4 over 3, 0. So these are your intercepts here, your axes intercepts. 0, negative 2. And 4 over 3, 0 right there. Okay. And so we can kind of get an idea that the graph is going to look something like that. Again, we did that a lot faster, but it might not be quite as accurate because these points, we only have 2 of them. We're not really connecting that many dots. The more exact points you plot, the more accurate your graph is going to be. And with this, we are only plotting 2 points. Now here's where you save even more time, because this takes many steps to convert into y equals mx plus b. If we just set x equal to 0, we're left with negative 5y equals, we'll move the 2 over, so it'll be negative 5y equals 5. Y is negative 1, so we have 0, negative 1. And if we set y equal to 0, we'll have negative 3x equals 5. X equals negative 5 over 3. So we have negative 5 over 3, 0. So we plot these 2 points, draw a line through them, and that's a general idea of what the graph looks like. Now, if you start out in the y equals mx plus b form, slope-intercept form, it's probably faster and more accurate to just do slope of 2, y-intercept of 4. But you can still use your intercepts. If we set x equal to 0, we just get y equals 4. So we get 0, 4. If you set y equal to 0, we get 2x plus 4 equals 0. So that means 2x will equal negative 4. X is negative 2. Negative 2, 0. So now here, plot these 2 points there. And we can see, if we did this good enough, that we should have a slope of around 2, which it looks like we do, up 2 over 1, and a y-intercept of 4. So in that case, it actually did work out to be pretty accurate. You may also save time with something like this, where you have a fractional negative slope. If we set x equal to 0, we get y equals negative 4. So 0, negative 4. If we set y equal to 0, we'll get negative 5 over 2x equals, there's nothing left over here now, so when the negative 4 moves over, it will become positive 4. We have a fraction here, so let's multiply everything by 2. X equals negative 8 over 5. And we'll get negative 8 over 5, 0. So now, plotting 0, negative 4 right here, and negative 8 over 5 right there. Oops. Let's just draw a small line there. Okay. Close enough. Again, here, we're not trying to get an exact graph. This is just a general estimate using this method. But I am using the exact same problems we did in the last video, and I think you can see that it does go faster this way. Set x equals 0, we get y is negative 5 over 3. And set y equal to 0, we get 1/6 x equals 5 over 3. Multiply everything by 6, we'll get 5 over 3 times 6 is 10. That's another risk here. Sometimes when you do this, you'll get points that are off the graph or almost off the graph. This is going to be, let's see, there's 0, negative 5 over 3, 10. I think 10 we can just make it'll be right here. So that's a risk when you use this method, is that you're going to get a point, an intercept that is off the graph, in which case you'll either just can't use this method, or you'll have to draw in an interval, put a number here, as we did. I believe we did that once. So anyway, this is probably not a method you're going to use often, but it's worth showing you as a faster way to get a general sketch, where you set x equal to 0 to find your x-intercept, and you set x equal to 0 to find your y-intercept, and you set y equal to 0 to find your x-intercept.